This video, we're going to talk about section 2.3, the inverse of a matrix. Note that I'm using my full screen on my desktop for this video so that I can show you my calculator as well as the work that I'm doing on the whiteboard. So make sure that you're watching this on a desktop or turn your phone landscape so that you can see everything, because you're not going to see everything if you leave your phone vertical. And hopefully you can see everything if you rotate your screen on your phone. And we're probably going to be doing that for most of the videos going forward, because we'll be starting to need to use our calculator more and more for these. But we're going to start off only needing to do the work here on the whiteboard. So number one gives us matrix A as 2, 1, 5, 3, and matrix B as 3, -1, -5, 2. And asks us to prove that A and B are inverses. So we want to show that A, B equals 1, 0, 0, 1, the identity matrix for 2 by 2s, and that BA also equals 1, 0, 0, 1, the identity matrix for 2 by 2s. So let's go ahead and show that. A times B is going to be 2, 1, 5, 3, 3, -1, -5, 2. That's going to be 2 times 3 is 6. 1 times -5, -5. 2 times -1, -2. 1 times 2, 2. 5 times 3, 15. 3 times -5, -15. 5 times -1, -5. 3 times 2, 6. And that is 1, 0, 0, 1, which is what I wanted to get. B times A is going to be 3, -1, -5, 2 times 2, 1, 5, 3, which is equal to 3 times 2 is 6, -1 times 5, -5, 3 times 1, 3, -1 times 3, -3, -5 times 2, -10, 2 times 5, 10, -5 times 1, -5, 2 times 3, 6, is also equal to 1, 0, 0, 1, which is what I wanted. So therefore, A and B are inverses. Let's do that again with problem number 5. And it says that A is equal to -2, 2, 3, 1, -1, 0, 0, 1, 4, and B is equal to, watch out, this says 1/3 of -4, 5, 3, -4, 8, 3, -8, 3, 1, 2, 0. So A, B is -2, 2, 3, 1, -1, 0, 0, 1, 4 times 1/3 times -4, 5, 3, -4, -8, 3, 1, 2, 0. So that 1/3 multiplier can come all the way out front. Without changing the answer. So this is 1/3 times -2 times -4 is 8. 2 times -4, -8. 3 times 1, 3. negative 2 times 5, negative 10, 2 times negative 8, negative 16. And then, have these right, negative 2, 2, 3, negative 4, negative 5, 3, negative 1, 0, negative 4, negative 8, 3, 0, 1, 4, 1, 2, yes. So negative 10, negative 16, and 6. And then that's a negative 5. That's what's wrong. So that's a 10. There we go. Negative 6 plus 6 plus 0. This is negative 4 plus 4 plus 0. This is negative 5 plus 8 plus 0. This is 3 minus 3 plus 0. This is 0 minus 4 plus 4. This is 0 minus 8 plus 8. And this is 0 plus 3 plus 0. So that's going to be 1/3 of 3, 0, 0, 0, 3, 0, 0, 0, 3. Multiplying 1/3 by every entry on the inside. This is 1, 0, 0, 0, 1, 0, 0, 0, 1, which is the identity matrix for 3 by 3s with 1s along the main diagonal, 0s everywhere else. Let's try b times a, which is going to be 1/3 of negative 4, negative 5, 3, negative 4, negative 8, 3, 1, 2, 0, negative 2, 2, 3, 1, negative 1, 0, 0, 1, 4. It's going to be equal to 1/3 times 8 minus 5 plus 0, negative 8 plus 5 plus 3, negative 12 plus 0 plus 12, 8 minus 8 plus 0, negative 8 plus 8 plus 3, negative 12 plus 0 plus 12, negative 2 plus 2 plus 0, 2 minus 2 plus 0, 3 plus 0 plus 0 is equal to 1/3 of 3, 0, 0, 0, 3, 0, 0, 0, 3 is equal to 1, 0, 0, 0, 1, 0, 0, 0, 1. All right, that was number 5. Let's go on now to number 13. Number 13 gives us a matrix A of 1, 1, 1, 3, 5, 4, 3, 6, 5 that we're supposed to augment with the identity matrix 1, 0, 0, 0, 1, 0, 0, 0, 1. And we're supposed to find the inverse of A by taking elementary row operations to get the identity matrix on the left. That's going to make A inverse show up on the right. Now, we are going to do these step by step, the same as if we did them by hand, but I'm going to show you how to let the calculator do the elementary row operations for you so that it does the arithmetic and you don't make an arithmetic mistake. So open up your matrix menu. We're going to edit. I'm going to make 3 rows by 6 columns. And this is going to be 1, 1, 1, then 1, 0, 0 for my identity matrix, 3, 5, 4, 0, 1, 0, 3, 6, 5, 0, 0, 1. All right, so I have a 1 in my upper left-hand corner already. That's great. I don't need to get a 1 there. Remember, I'm trying to get 1s along the main diagonals, 0s beneath them, and then I'll get 0s above them. So my 1 in the top left position is good. I'm going to use that 1 to get 0s beneath it. So I'm going to come out here, and I'm going to do second matrix math. Then I'm going to hit up, and I want to do this multiply a row by a constant and add it to another row. So the constant I want to multiply by is -3. And this is going to be in matrix A that I want to do this. And I want to multiply row 1 by that, and I want to add it to row 2 to produce a new row 2. And there we go. And so then I'm going to store that as second matrix A. And now I'm going to second. So I want -3 times row 1 added to row 3 to make a new row 3. And then I want to store that as matrix A. So now I've got my first column taken care of. Now I want to get a 1 in my second row. You've got some options here. I can do 3 minus 2 is 1, and then I can do some row swaps. But because we're using the calculator, let's just go ahead and make it deal with the decimals. So I'm going to multiply row 2 by 1/2. So second matrix math, and then multiply a row here. So I want my multiplier of 1/2, and this is in matrix A. And I want to do this to row 2. So let's store that as matrix A. Then we're going to take a -1 times row 2 to add to row 1. And then we're going to do a -3 times row 2 to add to row 3 to get 0s above and below it. So second matrix math, we want a -1 second matrix A, multiplying row 2 by -1 and adding it to row 1. And then we want to store that. And we want to take a -3 times row 2 plus row 3. And then we're going to store that You may say this seems like a lot of unnecessary steps. It's okay. This is the process in linear algebra. So now we're going to multiply row 3 by 2 to get a 1 down there. So second matrix, math, multiply, and then we have our multiplier of 2, matrix A, row 3, like so. We're going to store that. And you're going to see why I'm teaching you how to do this with the next problem. I'm doing this on an easier example that you could have done by hand, but we're getting ready for one that's not so nice to do by hand. So now I'm going to take -1/2 times row 3 and add it to row 2, and -1/2 times row 3 and add it to row 1. So second matrix. And you would be writing down each of these steps on your paper as you did it with the row operations. So you're not just letting your calculator do everything. If we wanted to let our calculator do everything, we would just be doing this in one step. So, but -1/2 in matrix A, we want to multiply row 3 and add it to row 2, like that. And we want to store that. And then we want -1/2, 3, and 1. And then we want to, there's our answer though for our inverse matrix is 1, 1, -1, -3, 2, -1, 3, -3, 2. So go ahead and write that down. I'll show you a couple of other ways though that we could have gotten that. So let's go back. I'm going to clear this. Let's go back and start off with second matrix A. And we're going to edit this, and I'm just going to put in the 3 by 3 for right now that we were given of show you here. This was 1, 1, 1. And then 3, 5, 4. And then it was 3, 6, 5. If I was just interested in using technology to find the inverse of this matrix, I would do second matrix A. I would use my inverse button right here, and my calculator would come up with the answer for me. So you're not, the process here is to show your teacher all of the elementary row operations that you would use to get there. I did them all with a calculator. Write them all down on your paper. Write all of your row operations out. You're not to the point yet where the teacher wants you to just use the inverse feature on your calculator. You will do that going forward. But this is learning all the elementary row operations and using them. So let's go ahead and let's look at, actually the next one's very straightforward. I'll just do it by hand. So the next one, 19, not even going to use the calculator for. A is 2, 0, 0, 0, 3, 0, 0, 0, 5. So I'm going to augment that 1, 0, 0, 0, 1, 0, 0, 0, 1. And I'm going to take 1/2 of row 1 to produce a new row 1. And that gives me 1, 0, 0, 1/2, 0, 0. 0, 3, 0, 0, 1, 0, 0, 0, 5, 0, 0, 1. Next step I'm going to take is 1/3 of row 2 to produce a new row 2. And that's going to give me 1, 0, 0, 1/2, 0, 0, 0, 1, 0, 0, 1/3, 0, 0, 0, 5, 0, 0, 1. My last step is 1/5 row 3 to produce a new row 3. That's going to give me 1, 0, 0, 1/2, 0, 0, 0, 1, 0, 0, 1/3, 0, 0, 0, 1, 0, 0, 1/5. I could do that faster by hand than with my calculator. What I'm not going to want to do by hand is number 21 with all of the decimals, and there's going to be repeating decimals. They're going to want the answer in decimal form. So number 21 has a that's given to me as 0.6, 0, negative 0.3, 0.7, negative 1, 0.2, 1, 0, negative 0.9. Now I'm going to want to augment that with my identity matrix. And this is not a technology problem in the textbook, so I'm not just supposed to throw it in and hit the inverse button and get the answer. I'm supposed to be using elementary row operations here. So the first thing that I want to do is I want to use that 1 that's already in column 1 by switching, say, row 1 and row 3. Let's go ahead and get this in here, though. So I want a 3 rows by 6 columns, and I want 0.6, 0, negative 0.3, 1, 0, 0, 0.7, negative 1, 0.2, 0, 1, 0, 1, 0, negative 0.9, 0, 0, 1. So let's go ahead and write down all the steps this time. I neglected to do that the first time that I was using the calculator, but let's go ahead and second matrix, let's go ahead and math. Let's swap in matrix A, row 1 and row 3. So 1 and 3 are swapped. And I'm going to make a new matrix A from that. So now I want to use that 1 to my advantage. I'm going to multiply row 1. So this was swap row 1 and 3 to give me 1, 0, negative 0.9, 0, 0, 1, 0.6, 0, negative 0.3, 1, 0, 0. This one stayed the same. Okay. So we have, let's take negative 7/10 times row 1 plus row 2 to produce a new row 2. So second matrix math times plus, so negative 0.7, comma, second matrix A, row 1 is multiplied, adding it to row 2 to produce a new row 2, like that. And then store second matrix A, and we get 1, 0, negative 0.9, 0, 0, 1, 0, negative 1, 0.83, 0, 1, negative 0.7, 0.6, 0, negative 0.3, 1, 0, 0. Now we want negative 0.6 row 1 added to row 3 to produce a new row 3. Second entry. So we're going to change this to negative 0.6 times row 1 added to row 3 to produce a new row 3. And then we're going to store that as matrix A. My new matrix A is 1, 0, negative 0.9, 0, 0, 1, 0, negative 1, 0.83, 0, 1, negative 0.7, 0, 0, 0.24, 1, 0, negative 0.6. So I almost have my 1 in my second column that I want. I just need to multiply row 2 times negative 1. So let's go ahead and do that. We have negative row 2 to make a new row 2. That's a pretty easy operation on here. Second matrix math, multiply a row. So we want negative 1, matrix A, row 2, Shazam. And there we go. We have our new matrix. I want to go ahead and store that so I don't lose it. If you do not store this every time that you do it, then you lose that transitional step that you had. It's going back to whatever the last saved state of the matrix was. So save every in-between step as once you've confirmed that your step was correct, that you took, and that you got your desired result of your 0 or 1 you were trying to get. All right, here's where you're really going to thank having the calculator, because we're going to be multiplying by 100 over 24, which is going to not be fun. So now we're going to multiply row 3 by 1 over 0.24. Let's see if the calculator can do that. So second, I've never tried to do it with a decimal in the denominator. Second matrix, math, multiply a row here, and we want to multiply by 1 over 0.24. This is second matrix A. We want to multiply row 3, and look at that. There we go, and it's got the repeating decimal in there and everything. Let's go ahead and save that. Second matrix A. So now we need to get zeros above that. So I should write this down. So this is negative, or this is 1 over 0.24 row 3 as a new row 3 is 1, 0, negative 0.9, 0, 0, 1, 0, 1, negative 0.83, 0, negative 1, 0.7, 0, 0, 1. And then we have 4.16 repeating, 0. And I need to look at that. I've saved it as matrix A. Need to come and see what's over here. And that's negative 2.5, right? So now that I've got all of that, I just couldn't see it all at once because it wasn't, this repeating decimal was keeping me from being able to see what was to the right there. Normally I can go ahead and hit enter and then scroll over, but it's not letting me. So anyways, I have everything from going back in there and saving that matrix. That's another reason to go ahead and save it. Now we want to take 0.83 times row 3 plus row 2 to produce a new row 2. And that's going to give me second matrix math. And we want to multiply, add, so my multiplier is 0.83. We're in matrix A. We want to multiply row 3, add it to row 2 to produce a new row 2. And so we have -1, 0, negative 0.9, 0, 0, 1. I'm going to go ahead and store this as matrix A so I can go in and take a look at it. Matrix, edit A, so I can see that this is now 0, 1, 0, just like I wanted. Now this is 3.458, and it looks like it's 3 repeating. Even though they threw a 4 on the end there, that is probably 3333333. -1, and then -1.375. Again, I prefer fractions to decimals, but this problem was in decimals. They want you to work it in decimals, but they want you to get a exact answer. So that's what we're going to do. 2.5. Then we need to take 0.9 times row 3 plus row 1 to produce a new row 1. So let's come out to my home screen and do that. Go into second matrix math, multiply and add 0.9, second matrix A, multiplying row 3, adding it to row 1 to produce a new row 1. And we have our identity matrix on our left-hand side that we wanted. Do not know how that happened, but I want to delete that. Apologies. 1, 0, 0, 0, 1. Now I'm going to have to store this as matrix A to go ahead and take a look at it because it's got even more repeating decimals in it now. Edit here. So this is going to be 3.75, 0, negative 1.25, 3.458, 3 repeating. -1, -1.375, 4.16 repeating, 0, -2.5. Trust me, you did not want to do that by hand without the assistance of a calculator. You could have done that a little easier by hand with fractions and then changing it to decimals at the end. But since we have our calculators available to us, let's go ahead and use them. All right, that was the last one of finding the inverse of a matrix by hand. Let's go on and let's look at number 29. And number 29 asks us to all right, we're on 25, and we still have a couple of these that ask us to find the inverse by hand, but we are going to have sometimes where we can't find an inverse, and I'll show you why here. So before we even get started with this one, if I have a row of zeros or a column of zeros that I can easily identify, or if 2 rows or 2 columns are identical, then I do not have an inverse to the matrix. It's what's called a singular matrix. So this one is singular because this row of zeros right here makes it singular. So singular matrix, no inverse. Okay. Number 29, so that was 25. 29 is A is 1, 0, 3, 0, 0, 2, 0, 4, 1, 0, 3, 0, 0, 2, 0, 4. And it does not matter which pair you look at, whether you look at this pair of rows that are the same, that identical with a difference of all zeros. So it's singular and no inverse. Same thing with if I had instead looked at this row and this row, they would also have been identical with a difference of 0. That would give me a row of zeros that would make it singular and no inverse. Okay. You can also see from what I was saying that if I have any column that is a constant multiple of another column, so column 3 is 3 times column 1, column 4 is 2 times column 2, I have row 1 and 3 are identical. So there's a whole bunch of ways I can look at this and say, oh, I'm going to get a column of zeros or a row of zeros if I do elementary row or column operations. And it's going to give me a 0 determinant. When I do that, when I get a row of zeros or column of zeros, and a 0 determinant tells me that the matrix is singular and does not have an inverse. Let's jump ahead now to number 33. And 33 says to find the inverse of the 2 by 2 matrix using the formula that's given to us in the book. The A inverse, this is for 2 by 2s, equals 1 over the determinant of A, which is AD minus BC, times, and then you swap places of A and D, where matrix A was A, B, C, D. So you swap places here and you change signs here, and that's going to give you the inverse of the matrix. So 33 was A is equal to -4, -6, 2, 3. So assuming that I can find a inverse of this, I would need to have a non-zero determinant. So let's go ahead and see if that's true first. The determinant of A is equal to -4 times 3 minus -6 times 2. So this is -12 minus a -12 is equal to -12 plus 12 is 0, which means A is singular and has no inverse. Number 37, have A is equal to 0, -2, -1, 3. So let's check before we go any further and see if we have a non-zero determinant here, since I can't divide by 0. 0 times 3 is 0, minus -2 times 1 is 2. -2 is my determinant. I'm in good shape. It's not 0. So A inverse is going to be 1 over -2 times switch positions of A and D, switch signs of B and C, like so. And then my inverse here is going to be is that what I'm supposed to do with 37? Well, this is part of what I'm supposed to do with 37. So 37 actually asked me to find the square of this inverse matrix, which we'll write as A to the -2. So let's first find A, -1. So this is -3/2, -1, -1/2, 0. So -3/2, -1, -1/2, 0. So if I'm going to square this to give me, and I'm going to use that notation, then I'm going to take this times itself, okay? And then this is one of the ways in which I can find a -2. So this is going to be 9/4 plus 1/2. And this is going to be 3/2 plus 0. This is going to be 3/4 plus 0. And this is 1/2 plus 0. So 9 plus 2 is 11/4. This is 3/2. This is 3/4. And this is 1/2. So 11/4, 3/2, 3/4, 1/2. So that is the first way in which I can find this A to the -2nd. Now, if I instead wanted to take A and square it first, I can do that. And that's going to give me 0 plus 2, 0 minus 6, 0 minus 3, and 2 plus 9. So that gives me 2, -6, -3, 11. All right. Now I can find the inverse of that. And I already know it has an inverse. So, I mean, I can find the determinant of this if I want to, just to be sure. Is 22 minus 18 is 4. So that's 1/4 times, swap these positions, and then change the signs here. And then I end up with 11/4, 6/4, 3/4, 2/4, and these even numbers reduce to give me 11/4, 3/2, 3/4, 1/2, which is exactly the same answer that I got the other way. So the order of these operations here, whether I squared and then took the inverse or took the inverse and then squared, didn't matter. That's what we wanted you to see with number 37. Let's go ahead and look at number 41. We're going to wrap up with that. 41 has multiple parts to it. So it says to use what we know about these inverse properties. So in the book, it says the inverse of A times B is B inverse times A inverse. For part B, where we find the inverse of the transpose, that's the transpose of the inverse. So the inverse of the transpose is equal to the transpose of the inverse. Transpose means making rows are columns and columns are rows. And if we have a constant multiplier times an inversible matrix that we're going to take the inverse of, then that's going to be the inverse of the constant multiplier times the inverse of the matrix there. So we have a non-zero constant multiplier because we don't want to take the reciprocal of 0 there, but any other scalar multiplier that's non-zero. So our information that we're given is that A inverse is equal to 2, 5, -7, 6, and the inverse of B is equal to 7, -3, 2, 0. So the first thing that I want to find is A, B inverse, which equals to B inverse times A inverse is equal to 7, -3, 2, 0 times 2, 5, -7, 6 is equal to 14 plus 21, and then 35 minus 18, and then 4 plus 0, and then 10 plus 0. So that's going to give me 35, and then this is 17, 4, and 10. Part B asks for a transpose inverse, which is A inverse transpose. So that is the transpose of 2, 5, -7, 6. So we make column 1 into row 1 and column 2 into row 2, and we're done. And then part C asks me for 2 times matrix A inverse, which is 1/2 of the inverse of A is 1/2 of 2, 5, -7, 6, which is 1, 5/2, -7/2, 3. That is it for this video, and we will come back next time to talk about our suggested problems from section 2.4. See you for the next video.